So today, let's dive into a very specific tool, one called number pieces from the Math Learning Center.
Okay.
And we're going to look at it through the lens of what I think is one of the biggest headaches in early math education.
Let me guess. The bridging 10 moment in subtraction?
That's the one. That exact threshold where so many first graders just, stumble.
Like doing 12 minus 5. It's a classic problem.
It is. And the sources for this deep dive suggest that the stumbling block isn't always the math itself.
Oh, what is it then?
It's the tools we use. It's a disconnect between the words we say and the materials the kids are holding.
You're talking about the Dienes blocks, right? The little wooden cubes and the 10 sticks.
Exactly. So let's play this out. A student needs to solve 12 minus 5. They put out one 10 stick and two single cubes.
Okay, I can picture that.
Take away the two ones, that's the easy part. They just slide them away.
But now they have the solid 10 stick left, and they still need to subtract 3 more.
And right there, that's the wall. You cannot physically take 3 cubes away from a solid stick of wood.
Right, so what do? We tell them to trade.
We do, but what's the word we use? We usually say unbundle the 10.
Ah, I see where you're going. We say unbundle, but what the student's hand actually does is a swap.
It's a swap. They put the 10 stick back in the box and take out 10 loose ones. The action completely contradicts the word.
That's a cognitive mismatch. A pretty big one for a 6-year-old.
It is. And that is precisely where this app, Number Pieces, offers just a brilliant pedagogical advantage.
So how does it handle it?
Well, it looks like a simple digital whiteboard. You drag the 10 stick and the 2 ones onto the screen, but when you select that digital 10 stick, there's a button. It's called Break Pieces.
Break pieces, so it doesn't just swap the image for 10 little ones.
No, that's the magic. It shows a seamless animation where the stick visually shatters. It fractures right there on the screen into 10 individual cubes.
Oh, wow.
It is literally unbundled.
That is a crucial difference. So the mental operation unbundling finally matches the visual representation. The quantity never leaves the workspace.
It just transforms. It closes that gap for the learner. They see 12, they take away 2, they break the 10, and then they can just slide the other 3 away.
The logic flows perfectly. There's no trading interruption to confuse their idea of place value.
And for a teacher, just think about this for a moment.
I can already see it. Using this on an interactive whiteboard in front of the class.
Yes. You can use the pen tool to circle the 2 you're taking away, write the equation on the side, and then you click that button and boom, the whole class sees the 10 break apart.
You're making the entire thinking process visible. That's so much more effective than holding up tiny little plastic bits.
It really is.
So what's the barrier to entry here? Is this a subscription? Are there, data privacy concerns for students?
None at all. And that's really important. It's a web-based app, it's completely free to use, and it's GDPR compliant.
So no logins or anything?
No login required. It's safe to use on student devices, not just for the teacher up at the front of the room.
So the takeaway here isn't really that digital is always better than physical.
No, absolutely not. Physical blocks are fantastic for so many things.
But for this one specific concept of unbundling, the digital tool is actually more didactically precise.
It's about finding the right tool for the job. If we want our students to truly understand unbundling, we should probably use a tool that lets them, actually unbundle.
It removes that translation error in their minds. That makes perfect sense.
So if you are teaching first grade, or you're supporting any student who's stuck on that transition, I'd say just open up the Math Learning Center website and try that Break Pieces function.
It's a small feature with a big impact. Definitely worth adding to the toolkit.
Absolutely. And it leaves you with a final thought, really. What other mathematical metaphors are we using in our classrooms that our physical tools might be accidentally contradicting? Something to think about. Thanks for listening.